Hello, my dear student. Today I am going to discuss about EDEXCEL IGCSE O-Level Physics. Today I am going to start a new series, Past Question Paper Solution. I start a new session, Year-wise Question Paper. My dear student, today I am going to solve Pearson EDEXCEL International GCSE 9-1 January 2021 Physics Paper 2. Instruction: use black ink or ballpoint pen. Use black ink or ballpoint pen. Fill in the boxes at the top of these pages with your name. Center name, candidate name. Answer all the questions. Answer the question in the spaces provided. There may be more space than you need. Show all steps in any calculation. State the unit. State the unit. Some questions must be answered with cross in box. If you change your answer or mind about the answer, put a line through the box and then mark your new answer with a cross. Information: total mark for this paper 70. The marks for each question are shown in the brackets. Use this as a guide as to how much time to spend each question. Advice: read each question carefully before you start to answer it. Write your answer neatly and in good English. Try to answer every question. Check your answer if you have time at the end. Formula sheet. You may find the following formula useful. Question number 1. Answer all questions. Question number 1. The photograph shows a security camera. This one is a security camera. The camera detects light waves and sound waves. State the difference between light waves and sound waves. Light waves and sound waves. Light waves are transverse wave. Transverse wave. On the other hand, and sound waves are longitudinal wave. Longitudinal wave. What is transverse wave? If the direction of vibration of the medium particle is perpendicular to the direction of propagation of the wave, perpendicular or 90 degree. Vibration of the particle, vibration of the medium, and propagation of the wave is perpendicular. These are transverse wave. On the other hand, longitudinal wave, if the direction of vibration of the medium particle is same as or parallel to the direction of propagation of the wave is known as longitudinal wave. So if the direction of vibration of the medium particle is parallel to the direction of propagation of the wave, it's known as longitudinal wave. Sound wave is an example of longitudinal wave. So sound wave is the example of longitudinal wave. This is the example of longitudinal wave. So light waves are transverse wave. On the other hand, sound waves are longitudinal wave. Light wave travels travel faster than sound. Light wave can travel through vacuum. Light wave can travel through vacuum. Light wave can travel through vacuum. But sound waves cannot. But sound wave can't. So what is the main difference between light waves and sound wave? Light wave is a transverse wave and sound wave is a longitudinal wave. Light waves travel faster than the sound. Light waves can travel through vacuum, but sound wave can't. Light wave is an electromagnetic wave. Light wave is an electromagnetic wave, but sound wave is a mechanical wave. Question number B. The camera detects infrared waves which allow the camera to record video in the dark. Which of these electromagnetic wave has longer wavelength than the infrared wave? Microwave. Microwave has longer wavelength than infrared wave. Remember, microwave is longer wavelength than infrared wave. Which of these is another use of infrared wave? Infrared wave also used as heating lamp. Which of these is a harmful effect of infrared wave? Skin burn is the harmful effect of infrared wave. The grid shows the oscilloscope trace for a quite low-pitch sound wave. The grid shows the oscilloscope trace for a quite low-pitch sound wave. The security camera has an alarm that produces a loud, high-pitched sound. On the grid, draw a trace to represent the sound wave produced by the alarm. So it has high pitch, that means frequency is higher, and loud sound, that means amplitude is higher. So Answer will be like this, because the security camera has alarm that produces a loud sound. If the sound is loud, then amplitude is higher. So trace drawn with higher amplitude throughout, because it has loud sound, because it produces loud sound. On the other hand, trace must be drawn with higher frequency, throughout. Next question number 2. The nuclear equation shows how a nucleus of uranium-236 may undergo nuclear fission. Here uranium atomic number 92, mass number 236, split into two smaller nuclei, atomic number 54 xenon and mass number 142, and strontium atomic number 38, mass number 94. So by calculating the mass number 140 plus 94, total mass in the right side is 234. So we need two neutrons, because here 236 is the mass of uranium, so 234, so by subtracting we get 2. That's why we get 2 neutrons in this nuclear fission reaction. Determine how many neutrons are released in this fission process. So answer will be 2. The table gives some of the constituents of nuclear fission. Complete the table by putting one tick in each row to show whether the constituent is a parent nucleus or a daughter nucleus. So strontium is a daughter nucleus, uranium is parent nucleus, and xenon is daughter nucleus. Because in nuclear reaction, the left side of the nuclear reaction, it is parent nucleus, and right side, that means product, are known as daughter nucleus. So xenon and strontium are daughter nucleus and uranium is parent nucleus here. Describe how the neutrons released in this fission process can cause chain reaction. Neutrons absorbed by neutron absorbed by another uranium (235) nucleus. Then it becomes unstable and it splits. Smaller nuclei and release more neutrons and process repeats. In this way, this fission process can cause a chain reaction. So, neutrons absorbed by another uranium-235 nucleus, then it becomes unstable. It splits smaller nuclei and releases more neutrons and process repeat. This way, this fission process can cause a chain reaction. Total for question 2 equal 5 marks. Now question number 3. A student uses this apparatus to investigate moments. Look at the diagram here. Force applied by Newton meter to the left direction. Elastic bands at 15 cm interval. Base of the clamp stand. This is the student's method. Attached elastic band at 15 cm intervals on a 1 meter tall clamp stand. Attached a Newton meter to the highest elastic band and measure the horizontal force required to tilt the stand. Repeat the method at each 15 cm interval. Question A. 3A. Name the instrument that the student should use to accurately measure the distance of the clamp stand. So meter rule or metal measuring tape. So name an instrument that the student should use to accurately measure the distance on the clamp stand. So meter rule or ruler, or metal measuring tape. The table shows the student results. Distance in centimeter, force applied in Newton. So when distance 15 centimeter, then force applied in Newton is 10 Newton. When distance 30 centimeter, then applied force is 5.6 Newton. If distance is 45 centimeter, then what will be the force applied in Newton? The photograph shows the reading on the Newton meter when the distance 45 centimeter. So 45 centimeter. Look at the position here. Pointer. So 3.6 Newton. It is the reading of Newton meter. This is the Newton meter. Reading of the Newton meter. Reading of the Newton meter is 3.6 Newton. 3.6 Newton. Use the photograph to determine the force required to tilt the stand when the distance is 45 centimeter. So answer is 3.6 Newton. 3.6 Newton. Give a reason why the Newton meter is unsuitable for measuring the force for distance less than 15 centimeter. Because the reading would be larger than the range of the instrument. Range of the instrument. Range of the instrument. Range of the instrument. Plot a graph the student result on the grid. Draw the curve of the base fit line. So look at the data first here. 15 centimeter, when the distance is 15 centimeter, then force applied. So distance in centimeter. Distance centimeter, and force applied in Newton. Here distance 0, 15 centimeter, 30 centimeter, 45, 60, 75 and 90 centimeter. On the other hand, force 1 Newton, 2 Newton, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 5, 1 2 3 4 5 6 7 8 9 10. So when distance is 15, force 10. When distance is 30, force is 5.6. Here it is 5.6. When a distance 45, then force 3.6. When distance 60, when distance 60, force is 2.6. Here it is 2 and 2.6. When distance 75, force is 2.2. 2.2 is here. When distance is 90, then force applied is 1.8. Now we can draw the base speed line. This is the base speed line. So the student concludes that the moment required to tilt the clamp piston does not change when the distance is varied. Use data from the table or the graph to evaluate the student conclusion. So, number 1 point, as the distance increases, force decreases. Number 1 point, decreases. Number 2, why? Because moment equal to force into perpendicular distance. That's why. So as the distance increases, force decreases because the moment equal to force into distance. Second thing, look at the data here. Moment equal to force into distance. So here one data, force is 10 Newton and distance 15 centimeter. So moment 150 Newton centimeter. Another data, check when force applied force is 3.6, applied force is 5.6, distance applied force is 5.6 when distance 30, 5.6 Newton, distance 30. Distance 30. So evidence shows moments are not all the same. So are not same. Can calculate 5.6 into 30, so 168 Newton centimeter. 168 Newton centimeter. So evidence shows moments are not all the same. All the same. All the same. But no pattern in the data. Pattern in the data. So relationship is non-linear. Relationship is non-linear. Question number 4. Question number 4. The bar chart gives information about how some of the electrical power in the United States of America, USA, was generated in the year 2018. Energy resource: coal, natural gas, nuclear, solar, water, wind. Percentage of electrical power generated in percent. In percentage. Most of the electricity generated in the USA uses non-renewable energy resources. Instead, what is the mean by the term non-renewable energy? Non-renewable energy. What is non-renewable energy? It will not run out or cannot, sorry, it will run out, sorry, it will run out, it will run out non-renewable energy. That means cannot be replaced, cannot be replaced. So non-renewable energy means we cannot reuse. That means it will run out or cannot be replaced. Determine the percentage of electrical power generated using the non-renewable energy resource shown on the bar chart. Non-renewable energy. Coal is a non-renewable energy. So here it is, non-renewable energy, coal, about 27.5%. Natural gas is a non-renewable energy. It is about 35%. nuclear energy is a non-renewable energy. It is about 19.5%. Solar, water, wind is the renewable energy. So we have to determine the percentage of electrical power generated using the non-renewable energy resources shown on the bar chart. So 27.5% plus 35% plus 19.5%. So about 82%. About 82, total 82%. 82%. So answer 27.5% plus 35% plus 19.5%. So total 82%. Total 82%. 82%. Question number B. In 2018, the USA generated more than half of its electrical power by burning fossil fuel. Explain one way that burning fossil fuel can be harmful to the environment. Fossil fuel is caused for global warming. Global warming. Or acid rain. Acid rain. The electrical power by burning fossil, by burning fossil fuel, fuels emits carbon dioxide, sulfur dioxide, nitrogen dioxide, The mean total electrical power output of the USA in 2018 was 4.76 10 to the power 11 watt. Calculate the mean electrical power output from the solar energy resources. Solar energy (1.5%). So solar output. So solar output 1.5% into 4.76 10 to the power 11. So 1.5 divided by 100 into 4.76 10 to the power 11. So about 7.14 10 to the power 9 watt. The mean total electrical power output of the USA in 2018 was 4.76 10 to the power 11 watt. A typical solar farm generates 250 watt of electrical power for every 1.1 meter square of land area used. Calculate the amount of land area needed if the USA were to generate all of its electrical power using solar energy resources. So, land area equal to total power total electrical power, total power divided by power of solar farm. So total power here 4.76 10 to the power 11 watt divided by solar power of solar farm 250 watt. So area will be 1.90 10 to the power 9 meter square. The total land area of USA 9.83 10 to the power 12 meter square. Discuss whether the USA could generate all of its electrical power using solar energy resources. No, because land area needed is much less than total land area of USA. There is another reason. Sun does not shine all the time. Another reason, some areas of land in USA may not be suitable for solar power. So total land area of USA 9.83 10 to the power 12. So discuss whether USA could generate all of its electrical power using solar energy resource. No, because land area needed is much less than the total land area of USA. Sun does not shine all the time, because sun does not shine all the time. Some areas of the land in USA may not be suitable for the solar power. Now question number 5. Transformers are useful in transmission of electricity. A. The diagram shows a step down transformer. What is transformer? Transformer is an electrical device which can convert one level alternating current to another level alternating current or voltage and vice versa. So it is a step down transformer because number of turns in the secondary coil is less than number of turns in the primary coil. So input coil is known as primary coil and output coil is known as secondary coil. Give a name suitable metal that would be used the core transformer. Soft iron core. Soft iron core. Iron core is used as core of the transformer. Soft iron core. Or any ferromagnetic material or any ferromagnetic material. Any ferromagnetic material. Ferromagnetic material. Ferromagnetic material. State the formula linking input power and output power for a transformer. It is considered transformer is 100% efficient. That's why input power equal to output power. Output power. Because 100% efficiency of the transformer is 100%. That's why input power equals to output power. Input power equals to output power. Or you can write input power, that means primary voltage into current, primary voltage into primary current equal to output voltage secondary voltage into secondary current. The step up down transformer has an input voltage 275 kilovolt and output voltage 230 volt. Output voltage 230 volt. The transformer has output current 95 ampere. Calculate the input current in the transformer. We know primary voltage into primary current equal to secondary voltage into secondary current. So here 275 kilovolt into primary current. We have to find out the primary current IP equal to secondary voltage 230 and secondary current 95 ampere. First we have to convert 275 kilovolt, that means into 1000 equal to IP. IP means primary current 230 into 95. So IP equal to 230 into 95 divided by 275,000. So answer will be 0.079 ampere. 0.079 ampere. Explain how transformers are useful in the large-scale transmission of electricity. You may draw a diagram to support your answer. Here is the power station. It is power station. Power station. In power station, there's high current at low voltage. If this high current transferred through transmission line, then due to high resistance, there produces a large amount heat. So we have to convert this high current to low current by using a step-up transformer. Step-up transformer convert step-up transformer. Step-up transformer, just the transmission line, it is a pillar. Transformer. So this step-up transformer converts high current into low current and low voltage into high voltage. So high voltage at low alternating current. Because transformer works for only alternating current. Then when it reaches to the consumer unit, again we need to use another transformer, step down transformer. The number of turns in the primary coil input is more, and in the secondary coil it is less. This is a consumer unit. Step down transformer. Low voltage at high current. Alternating current. So step-up transformer, used before transmission. Voltage is increased before transmission. Before transmission. Current is reduced. Current is reduced before transmission. So less heating in transmission cable. So less heating in transmission cable. Less energy wasted in the transmission cable. So less energy wasted in transmission cable. Transmission. and step down transformer used after transmission. So step down transformer used after transmission. Question number 6. The Hertzsprung-Russell diagram shows the relation between the absolute magnitude and color of stars. Absolute magnitude and color of the star. The position of the sun is shown on the Hertzsprung-Russell diagram. Star W is a white dwarf. Add a W to the Hertzsprung-Russell diagram to show the position of the star W. Star X is a red giant. Add an X to the Hertzsprung-Russell diagram to show the position of the star X. Star Y is a main sequence star that is much larger than the sun. Add a Y to the Hertzsprung-Russell diagram to show the position of the star Y. Star Z has the same surface temperature as the sun, but would be dimmer than the sun if it were the same distance away from the earth as the sun. Add a Z to the Hertzsprung-Russell diagram to show the position of the star Z. First, we have to draw the Hertzsprung-Russell diagram or HR diagram. It is main sequence star, main sequence star. Then this is the position of the supergiant. It is white dwarf. And it is for giant, red giant or only giant. So star W is a white dwarf. So add a W to Hertzsprung-Russell diagram to show the position of the star W. So W position is here. W position here. Then star X is a red giant. So red giant. So X, red giant. Star Y is a main sequence star. That is much larger than sun. Sorry, Y. This Y. and star jet has the same surface temperature as the sun, but it would be the dimmer than the sun if they are the same distance away from the star as the sun. Add jet to the Hertzsprung-Russell diagram to have the position of star jet. So position of the jet will be below the sun. Now the moon is the brightest object in the night sky. Suggest why the moon cannot be shown on the Hertzsprung-Russell diagram. Because the moon does not emit its own light. Moon is not a star. Moon is not a star. Not a star. Question number 7. Question number 7, the diagram shows a child's toy for accelerating steel balls. This is how the toy works. The toy uses 3 identical steel balls. Each with a mass of 4.1 gram. Ball A moves towards the magnet. The ball B is contact with the magnet. Balls B and C are initially at rest and are in contact with each other. When ball A collides with the magnet, the ball C moves away from the magnet. Ball A moves towards the magnet with an initial velocity 0.15 meter per second. Calculate the initial momentum of ball A. The mass of the ball A is 4.1 gram. So we know momentum equal to mass into velocity. Here mass 4.1 gram into velocity 0.15 meter per second. We have to convert this gram into kilogram. 4.1 divided by 1000 into 0.15 meter per second. So initial momentum will be 0.0062 kg meter per second. So initial momentum of ball A will be 0.00062 kg meter per second. Ball A is attached to the magnet. Explain how this attraction affects the momentum of the ball A as it approaches the magnet. The velocity of ball A increases. as it approaches the magnet. So the momentum of ball A increases. Question number C. When ball A collides with the magnet, the force of 1.3 Newton is exerted on ball C for a time of 0.0025 seconds. This causes ball C to move away from the magnet. Calculate the change in velocity of the ball C due to this force. We know force equal to mv minus mu divided by t. That means change in momentum divided by time taken. Here force 1.3 Newton equal to mass 0.0041 into final velocity minus initial velocity. Initial velocity was 0 divided by time. Here time is 0.0025 seconds. So velocity will be 1.3 into 0.0025 divided by 0.0041. So about 0.79 meter per second. So change in velocity will be 0.79 meter per second. So last question for this paper, question number 8. The diagram shows a simplified view of part of an inkjet printer. Negative charge plate, positive charge plate, negatively charged ink droplet. A negative charged ink drop falls vertically between a pair of charge plates. The ink drop experiences a horizontal electrostatic force as it falls. Explain the direction of the electrostatic force exerted on the ink drop by the charge particle. So, force experienced on the ink drop by the charge plate will be to the right, because opposite charges attract and like charges repel, So this negatively charged plate repel the negatively charged ink droplet. On the other hand, positively charged plate attracts negatively charged in drop. On the diagram, draw the path of the in drop as it falls between the charge plate until it hit the paper. Question number C. 1. The ink drop experiences a horizontal force 8.5 10 to the power minus 7 Newton when it is between the charge plate. The mass of ink drop is 1.1 10 to the power minus 10 kg. Calculate the horizontal acceleration of the ink drop when it is between the charge plate. We know force F equal to mass into acceleration. So A equal to force divided by mass. Here force 8.5 10 to the power minus 7 and mass of the in drop is 1.1 10 to the power minus 10. It's Newton and it's kg. So answer is 7,700 meter per second square. So acceleration of the in drop will be 7,700 meter per second square. The in drop has no initial horizontal velocity before it passes between the charge plate. After passing between the charge plate, the horizontal velocity of the in drop is 3.9 meter per second. Calculate the horizontal distance traveled by the in drop as it passes between the charge plate. Give your answer in millimeter. We know V square equal to U square plus 2AS. Your final velocity 3.9 meter per second square, initial velocity 0, and 2 A is 7,700 meter per second square. We have to find out S. So S will be 3.9 square divided by 2 into 7,700. So distance will be 9.9 10 to the power minus 4 meter. In millimeter it is 0.99 10 to the power minus 3 meter. That means 0.99 millimeter. So answer 0.99 millimeter. Last question. D. Explain how another in drop could be reflected in the opposite direction by a greater distance using the charge plate in the inkjet printer. Swapping the polarities of the charge plates. So by alternating the polarities of the charge plate, by increasing the amount of charge on plate. Total for question 8 is 13 marks and total paper 70 marks.